Hey guys, welcome to multiplication and division of algebraic fractions part 2. So in this particular video, I'm only going to be looking at two questions, but kind of think of it like little hacks to actually deal with multiplication and division. So let's have a look at the first question here. Now, instinctively, what you want to do is you basically want to expand the brackets, particularly with the numbers, all right? That's what people want to do. So when they see 12 squared at the bottom, they want to write that as 144. What I do want to show you guys is how to calculate this without a calculator. Okay, so the first step is you do need to take things out of the brackets. So I'm going to look at the top numerator here, which is this one. So we got 2 to the power of 3. So I'm going to write that as 2 to the power of 3, x to the power of 3, and then y to the power of 9. Multiplied by, I've got 6 squared. So I'm going to write that as 6 to the power of 2, x to the power of 4, and y to the power of 2. And in the first fraction's denominator, I've got 3 squared, x squared, and y squared. And as for the second one, and I guess this is where I want you guys to see what the heck is. Like, for example, you've got 12 there, okay? Now, I don't really want to write 12 squared, but what I do know is 12 can be written as 6 times 2. So what I would like to do is, I'm going to rewrite 12xy cubed as 6 multiplied by 2xy cubed squared. Well, because that's what's getting it squared. So when I actually do that, what happens is I'm going to have 6 squared multiplied by 2 squared, and then I've got the regular, which is x squared and y to the power of 6. Now the reason I wanted to do 6 squared is because then I will be able to do this, because 6 squared and 6 squared cancel out each other. And then have a look at what else I can actually cancel out. So the next thing I'm going to cancel out is, oh, there we go, the 2's. So there is a 2 to the power of 3 here and 2 squared in the denominator. So 2 to the power of 3 can be, well, that cancels out just to be left as 2 to the power of 1. 2 squared disappears. Next thing I'm going to be looking at is x to the power of 4 in the numerator here. And I've got x squared here and x squared here. So I know that that and that will cancel out with that, because x to the power of 4 divided by x squared is x squared, and then divided by another x squared is just 1. So what I've got left over, I've got, oh, there's y squared. So I can cancel out the y squareds. Y squared and y squared. What else can I get rid of? Y to the power of 9 and y to the power of 6. So those two will cancel out each other, but in the numerator I'm left over with y to the power of 3. And I think that's basically it. So what have I finally got left over in the numerator? I've got a 2, I've got an x cubed, and I've got an y cubed, and that's divided by 3 squared. Okay, so you can actually leave it like that, or you could just write it as 2x cubed y cubed divided by 9. That's basically it. Okay, let's have a look at another variety of problems. So this time, I'm not putting any variables in there. I'm actually giving you guys numbers. So how do we go about working this one out? And it was very similar to the trick that I taught you earlier with the 12. So when you actually have 50 to the power of 3, and you've in the denominator you've got 10 and 5. So what I would do is I would actually write 50 as 5 times 10 to the power of 3 divided by 10 to the power of 3 times 5 to the power of 3. Now, because of the division symbol, I'm going to change it to multiplication symbol, and I'm going to write the reciprocal of this particular fraction. So I'm going to get 5 to the power of 4 divided by 25 cubed. Okay, so let's have a look at that first, the blue fraction here. So with the blue fraction, I've got 5 cubed multiplied by 10 cubed divided by 10 cubed multiplied by 5 cubed, and all of this is multiplied by 5 to the power of 4 divided by, now I got 25. Now I know that 25 can be written as 5 squared, and that's what I'm going to do, because watch this, 25 to the power of 3, I can write it like this, something like this, 25 to the power of 3 like this. I know that 25 is 5 squared, and so I can rewrite this as 5 squared to the power of 3. Now 5 squared to the power of 3 is actually 5 to the power of 6. And that's what I'm going to replace in the denominator here. So let's see what we can cancel out, what we can get rid of, and what we leave over. So 5 cubed and 5 cubed disappear to make 1. Then we have 10 cubed and 10 cubed disappear to make 1. So all we're left over with 5 to the power of 4 divided by 5 to the power of 6. So in this case, we know that 5 to the power of 4 cancels out to just become 1, and 5 to the power of 6 cancel out to become 5 squared. So all we're left over with is 1 over 5 squared, or we can say that this is 1 over 25. So you can do these problems without calculators, folks. Just need to understand how to manipulate the powers. And trust me, this is a skill that's going to come very useful for you come end of the year. All right, that's it for this session, guys. If you have any questions, pop it in the comments below. Also, don't forget to like, share, and subscribe. And thank you for watching.